All right, good morning, guys. It is Monday, April 20th. Starting into a new lesson. I'm going to expand a little bit upon some of the iReady lesson things that are out there. So, talking about probability these last 2 weeks, so week 3 and week 4, all revolve around the idea of probability. All right, and probability is simply the chance that an event happens. All right, they talk a lot about likeliness, all right, or how likely something is. All right, so. When it comes to probability, you're typically going to see probabilities or use probabilities as fractions or percentages, but like all things we've talked about all year with number sense, all numbers can be converted into both fractions, decimals, and percentages. So when it comes to probability, there is nothing greater than 100% chance of something happening. If so there's a 100% chance, it is certain it's going to happen. All right. That's a 1, or as a fraction, it would be however many outcomes there are, the numerator and denominator would be the same thing. All right, it's certain to happen. And the same thing, there's never less than a 0% chance. 0% chance means it will not happen. All right, it's impossible. So everywhere between the whole number 0 and the whole number 1 is where all the rest of the probabilities fall. All right, so between 0 and 100%. All right, if it's exactly in the middle, 0.5, 50%, 1/2, all right, or any equivalent fraction to 1/2, that means it's equally likely that it will or will not happen. All right, we can't use a word like maybe. All right, maybe would be anything between 0 and 100%, and we're just not going to use it. All right, you guys hear maybe probably from parents or friends or something like that sometimes. Hey, can I do this? And if the answer is maybe, all right, sometimes that means yes, sometimes that means no. It doesn't mean it's equally likely. It might depend on what mood mom and dad are in. So we're not going to use words like maybe. All right, so if it's less than 50%, all right, it's not likely, all right, or less likely, but that doesn't mean impossible. All right, so you'll see things like highly unlikely. Highly unlikely would be closer to 0 than it is to 1/2. All right, unlikely would be anything less than 1/2. All right, same thing going the other way. So highly likely, all right, would be up toward 1 but not 1, or up toward 100% but not quite there, meaning there's a chance that it could not happen. All right, so when it comes to probabilities, all right, how you're going to calculate that and get those percentages or fractions or decimals is you're going to look at outcomes. All right, so when you're going to calculate it, you're looking at a fraction, all right, that you can change to a fraction or to a decimal or percent. All right, and what we're looking for is the desired or tested outcome and divided by, or as a fraction, the number of possible outcomes. All right, and there could always be more than one desired tested outcomes as well. All right, so anyhow, we think of things like with probabilities, fair type games and things like that, the Fireman's Festival, a lot of probabilities are in like that. So let's say you're up there at the Fireman's Festival and you're playing a spinner game. And the game you'll win if you hit certain numbers, but if you hit other numbers, you'll lose. And that depends upon the number of spaces on the spinner. All right, so let's say in this situation, you're looking at a spinner with 20 equal sections. All right, and they are numbered, let's just go with 1 to 20. All right, on that number 1 to 20. All right, when you spin that spinner, as long as it's fair and not weighted any certain way, and it goes around and ticks, it has a 20 possible outcomes. So that would be the denominator in this case. And then depending on what the game is. So if they say the game is you win 17 or higher. All right, if you get a 17 or higher, you win the game. All right, what is the probability you're going to win that game? So with that, the probability would be the number of desired or tested outcomes. What to win, we would desire to have 17 or higher. That'd be 17, 18, 19, and 20. You're looking at 4 outcomes. All right, out of how many possible? Obviously 1 through 20. There's 20 outcomes, so 4 divided by 20. All right, fitting, I guess, today's April 20th. All right, 4 divided by 20 is point.
And now I'm getting ready to make a mistake, believe it or not. 4 divided by 20 is 0.2 or 20%, not 25% like I put there. You would all be laughing right now.
Obviously, no, it's under 1/2. It's not likely. It's not equally likely. It's unlikely. You might not say highly unlikely, because there's a chance. 1 out of 4 is a chance, but not likely that you'll win that game. Those are called simple probabilities. All right. So theoretically, what happens mathematically is 4 out of 20 chance. All right. All right, and we can do a lot of different examples of those. Coin tosses, numbers, rolling dice, all those kinds of things. So there's also then something called experimental probability. Experimental probability are chances. Again, probability means chance. Probability that something will happen, but it's not based upon the possible outcomes. It's really based upon the idea of what really happens. All right. I always use this example in class of getting struck by lightning. All right. We all know that that's an unlikely occurrence. All right, but if we went on possibilities, all right, you're going to walk outside, and there's 2 possibilities. You're either going to get struck by lightning or you're not. All right. So if I said you have a 1/2 chance or a 50% chance of being struck by lightning outside, I think there's very few of us who would ever walk outside. All right, so that's not the probability we're looking for, right? There's 2 outcomes, all right? Only one of them that's being tested for, your chance that you will get hit by lightning. All right, but it's not an outcome that's based upon a fair number of trials, all right, or a fair thing. It's not possible. So what we look at is experimental probability, all right? And then that is based upon actual trials. All right, I don't know all the science that goes into how they would calculate your chance of getting hit by lightning, but it would have to do with the number of lightning strikes that are recorded versus probably the number of reported people being struck by lightning, and obviously the chances of that are thousands or millions of percentages, so a very small opportunity for that to happen. So they track the number of bolts of lightning that are maybe connect with the ground, and then see how many within a year are recorded, and they say your chance of getting hit by lightning is 1 in 5 million, so a very small percent chance or anything like that. That's an experimental probability, but what you use experimental probability for is to then predict. All right, so we use it to predict. All right, so for example, if we have experimental probability that a person's favorite color is green. And that probability is, let's go with 20%. All right, meaning there was was an experiment that was posted. So let's say it was everybody in the school, 500 kids were asked, or that's middle school, 400 kids were asked, and out of those kids, 20% said green. All right, we could use that to say, okay, based upon this experimental probability, then we would look at the idea that everyone, if everyone were asked, it would be 20% chance their favorite color was green. So if I were to ask everybody in Johnstown, 5,000 people, I'm making that up right now. All right, so we have 5,000 people were asked. How many would say green? All right, well, then it's 20% or 0.2 of 5,000. 0.2 of, we've talked about many times being 5,000. 0.2 times 5,000. And you could say, okay, if we asked everyone in Johnstown, if there was a 20% chance their favorite color is green, how many people would say green? All right, well, that's 200 for every 1,000. All right, so you're going to end up with 1,000 people as an answer. So you're going to use it to make predictions and things like that. All right, based on results. That's experimental probability. And finally, one of the last concepts that are on your iReady lessons are compound probability. All right, compound probability is the probability of multiple events happening. All right, so when you think compound, just like compound sentences or elements or scientific things like geology, rocks and stuff, that compounds are things put together. So these are multiple events. All right. So multiple events happening in a row. Or even at the same time. All right, so with compound probability, this is the idea that, let's go with rolling dice. All right, if you roll 2 dice, and we want a total of 12. Alright, and we'll just say these are standard 1 through 6 number cube dice. Alright, so you roll 2 dice and get a total of 12. So now you start looking at, okay, what are all the possible outcomes? Alright, on dice, I can roll 2 dice, and on die number 1, I can get a 1, 2, 3, 4, 5, or 6. And on a die number 2, I could get the same exact outcome, say 1, a 2, or 3, 4, 5, or 6. Now it doesn't matter if I roll those together at the same time or if I roll them one at a time, they each both have the same outcomes. Alright, I want a total of 12. I must have written, oh there it is. A total of 12. The only way I can do that is if I get a 6 and a 6. Alright, well what's my probability of getting a 6 on the first die? Alright, it's a 1 out of 6 chance. What's my probability of getting a 6 on the second die? It's also a 1 out of 6 chance. Alright, so this is where you can start to think about, okay, if I have a 1 out of 6 chance, is that likely? The answer is no. If I have a 1 out of 6 chance on the second, is that likely? The answer is no. Not impossible. But as I do one thing that's not likely, to do it again, it's not likely either. Alright, it's not like my chance stays the same, it gets worse. Alright, if it wasn't likely the first time, it's going to get worse the second time. So with these, you can start to do different things. I mean, if you look on the iReady lessons, it shows you different models you can make to count outcomes. Alright, but there's also then just a shortcut to it for compound probability. Alright, what you can do is multiply each probability. So in the case of those dice, so in that example, I had a 1/6 chance times another 1/6 chance. And I will get with that, obviously 1 times 1 is 1, 6 times 6 is 6. I have a 1 out of 36 chance. Change that into a percentage, you're looking at less than 3%. I don't have a calculator on me right now, but that's 3% would be 1 out of like 33, so a little slightly under 3%. So we'll say about 3% is probably like 2.8 or something like that, if I were to get a decimal for that. So your probability of rolling when you play a board game or anything like that, maybe you're playing a lot of board games right now, I know my family is. You think about Monopoly, your chances of getting 12, is about a 3% chance. So that's the idea, the concept behind compound probabilities. If you just want to know how many outcomes there are when you roll dice, let's think about another example. Not dice, let's think about flipping a coin. There are 2 possible outcomes when you flip a coin. You got heads and you have tails. If I flip that same coin 4 times, that'd be 4 flips. Every coin, the outcomes are heads or tails. And I say, okay, what's my chance of flipping tails every single time I flip that coin? A lot of times students want to say 1/2 and they instantly go with that. Or then they pick another number or whatever. But the idea is I want tails every single time I flip the coin. I do it 4 times. That's 4 events. 4 events. The event of flipping, or the chance of flipping tails on the first coin is 1/2. Tails on the, equally likely, tails on the second coin, 1/2, 1/2, and 1/2. What is my compound probability? If you look back at the last example, or what you do, multiply those together. 1/2 times 1/2 times 1/2 times 1/2. If you remember, I said 4 times in a row. All of a sudden, your probability, which was 50%, gets worse, worse, and worse. Say a total of 1 out of 16. So 1 in 16 chance. Or what's that, about 5%? 6%. Just slightly over 6% chance, if you look at that. All right, so those are some concepts, maybe going along with your iReady lesson, that will help you not just prepare for, or understand probability, but prepare for your assessment that you'll take on Friday. Email with questions and get caught up on those reassessments if you haven't finished those that are posted online under the assessments tab. So hope all is well. Have a great week ahead of you.